Hello dear friends, it's been a while. I welcome you once again to my channel where mathematics is made easy. Today's video we are going to talk about the modulus and direction cosines of vectors in 3 dimensions. I'm going to take you around vectors in 3 dimensions. I will not just give you the formula that will help you solve this question. I'm going to make you to understand why the formula is so. So we are going to make a very good breakdown of the topic vectors, the modulus of vectors in 3 dimensions. Remember, when we mention the word modulus, it can be seen as the magnitude of a vector, as well as we are going to talk about the direction cosines of vectors in 3 dimensions. If this is your first time of viewing, consider subscribing to my channel to be notified whenever I upload a new content, because in my next video I will discuss the unit vectors, so that you understand actually what these vectors are all about. Kindly subscribe to my channel for notifications. Alright, so before I go into the solutions to this particular problem, I want you to understand what vectors in 3 dimensions is all about. Take for instance, if you have a vector, let's say this is a vector A. If you want to get the magnitude of this particular vector, you can see that this vector has moved in the x-axis direction. It has also moved in the y-axis direction. It has also moved in another direction, which we can say, let's say z. So you can see that this has moved into 3 different directions, and that is the magnitude of this particular vector. And how do you resolve this? You understand this thing appropriately when you consider a cuboid or a cube. So let's take an example. Let's see this as a cuboid. So assuming this is a cuboid, this is that x direction it has moved. This is the y direction, and this is the z direction. Okay, so now this is now the magnitude from this particular point to this particular point, and that is the vector A. So this is just the magnitude of these 3 vectors x, y, and z. You can see the intersection and look at that vector A we are seeing here. Okay, now for we to be able to get the magnitude of this vector, we are going to draw another diagonal on the base of this cuboid. So let's take this as another diagonal. Remember, if here is z, automatically here will also be z, because opposite sides are equal. Now let's consider this particular vector here, which you don't know as, let's say, vector p. Let us get the value of this vector p, the magnitude. So you see that this and these are in a right angle. Also, this and these are in a right angle to each other. So let us bring out this particular base triangle now, which I have something like this. When we bring it out, the base, this is the right angle, where here is our z, here is our x, and here is p. From Pythagoras theorem, we can see that p squared is equal to x squared plus z squared. This is just the value of p squared, and there is nothing else I can do to it. I can call it equation 1. Do you know it's possible bringing out this triangle again, p triangle APY, this particular triangle here, where our vector A is the hypotenuse? So I can have something like this. This is now the vector A. This is at right angles, and this is my y, this is my p. Now if I happen to make A the subject, which is the hypotenuse, I'll have that my A squared is equal to p squared plus y squared. All right, so let me clean up here and continue. So you've seen that my A squared is equal to p squared plus y squared. Now from here we can see p here, p is common. So let me make a value for p. Making p subject here, I'll have that my p squared will be equal to a squared minus y squared, because when this y comes here, it becomes minus. So this particular point that I'm seeing p squared, I will just put in a squared minus y squared. So coming here, p squared, I'll write a squared minus y squared will now represent p squared equals x squared plus z squared. Now this negative y can cross over, it becomes positive. Therefore, my a squared will now be x squared plus y squared plus z squared. Now to get the value of a, which is the magnitude of this vector we are looking for, we shall now have that a is now square root of x squared plus y squared plus z squared. So this is the formula we use in getting the magnitude of a vector in 3 dimensions. Unlike the magnitude of a vector in 2 dimensions we talked about, where we normally stop at y squared because it is in 2 dimensions. Now that is in 3 dimensions, you're going to take the x squared, the y squared, and also the z squared. That's how to get the magnitude of vectors in 3 dimensions. Also, we have what we call the direction cosines of vectors in 3 dimensions. So let's take a look at the direction cosines. If you followed my videos on the 2-dimensional vectors, you understand what I meant by direction cosines, where we have cos alpha and cos beta only. But because this is in 3 dimensions, we shall have cos alpha, cos beta, and cos gamma. So cos alpha will be, let's say, x over the modulus of the given vector. Now we are talking about vector A, so it will be modulus of vector A. So this is the value. Remember, this A modulus is the something as this. Now, cos beta will give us y over the same modulus of A. Remember, this is the modulus I'm talking about. I can put this there. Now, cos gamma will give me z over modulus of the same A. So this is just the direction cosines. Alpha x, beta y, and gamma is just z. So from this little thing we've learned, let us use it to solve this question at hand. So in the first question we have R1 equals I minus 2j plus 3k. Now remember that my x is the coefficient of I, which is 1. My y is the coefficient of j, which is negative 2, and my z coefficient of k, which is just 3. Okay. Now the modulus of R1 is equal to square root of x squared plus y squared plus z squared, which will now give me modulus of R1 will be equivalent to square root of my x will now be 1 squared plus my y minus 2 squared plus my z, which is 3 squared. As I continue from here, so modulus of R1 will just be square root of 1 squared is 1 plus negative 2 squared is 4 plus 3 squared is just 9. So my R1 will give me square root of 1 plus 4 is 5 and 5 plus 9 is 14 units. So since 14 is not a perfect square, we can leave it like that. If you like, you can still take the square root to get a negative 3 point something. Okay, now direction cosines. So I have my cos alpha, which is x over modulus of R1. My x is just 1, so it will give me 1 over root 14 because x is 1. Now cos beta will be y all over R1, and my y is just negative 2, so it will give me negative 2 over root 14. And my cos gamma, which is z over modulus of R1, will give me my z is just 3 all over modulus of R1. These formulas, the way they came to be, we discussed it in the previous video, so you can consider going to my playlist where I have vectors, my playlist. So from there, you can refresh your minds on how these formulas came to be. Okay, so let's take the second question where we have that R2 is equal to negative 3i plus 2j minus 6k. So this is R2 equals negative 3i plus 2j minus 6k. Okay, now my x is negative 3, my y is just 2, my z is negative 6, and the modulus of R2 will give me square root of x squared plus y squared plus z squared. Hence, modulus of R2 is the same thing as square root of my x is minus 3 squared plus y, which is 2 squared plus z minus 6 squared. So I'll continue from here. So modulus of R2 will give me 3 squared, negative 3 squared is 9, 2 squared is 4, and negative 6 squared is 36. When I add together, I'll get 49. So modulus of R2 is just square root of 49. And square root of 49 will give us 7 units. So the modulus of R2 is just 7 units. Now let us get the direction cosines. So we have our cos alpha, which is x over modulus of R2. And my x is just minus 3. So to give me minus 3, our modulus is just 7. We go for cos beta, the direction cosines is y over modulus of R2. And my y is just 2. So I will have 2 over modulus of R2, which is still 7. Then finally, cos gamma, which is z over modulus of R2. And my z is minus 6. So to give me minus 6 over 7. Okay, so this is how you can get the modulus and direction cosines of vectors in 3 dimensions. In my subsequent video on vectors, I'm going to discuss the unit vector. If you've enjoyed what you've watched, kindly subscribe to my channel to be notified whenever I upload a new video. Thank you.